Hey guys, I'm continuing straight on from the previous video. So we're now up to the third method, which is Gaussian elimination. So Gaussian elimination, I'm just going to rewrite our formulas. We had 2x1 minus 5x2 equaling 1, and 3x1 plus 5x2 equaling 14. I'm just going to call this equation 1 and this equation 2. So, to do Gaussian elimination, you essentially need to isolate different variables and then just substitute them in. So, what we're going to do is we're going to go from 2. We're going to get x1 by itself. So we're going to write from 2 we have 3x1 equaling 14 minus 5x2. Then dividing through by 3, we would have 1/3 outside of 14 minus 5x2. So we isolate the variable. We then substitute that into the other formula. So we're going to sub for x1 into equation 1. Okay, we took it from 2, so we need to go into 1. So if we substitute for x1 in equation 1, we would have 2 outside of 1 on 3 outside of 14 minus 5x2 minus 5x2 equals 1. So simplifying this, I'm going to multiply everything by 3 and expand this out. So multiplying everything by 3, we would have 2 outside of 14 minus 5x2 minus 3 by 5 is 15x2. 3 by 1 is 3. Now expanding this left part out, we would have 2 by 14, 28, minus 2 by 5, minus 15x2 equals 3. Collecting like terms, so we're going to get minus 10x2 minus 15x2 would be minus 25x2. Putting down the right hand side, we would have 25x2. 28 minus the 3 would be 25. Dividing through by 25, we would have x2 equals 1. We then would just substitute that back in to the formula we developed here. Now this was 2. I'm going to call this 2a. Subscript a is denoting the fact that I got this equation from equation 2. It's just in a different form of x1. So I'm going to write sub for x2 into equation 2a. So we would have x1 equals 1/3 outside of 14 minus 5x2, where x2 is 1, closing the bracket. If you were to solve this, you would find that x1 equals 3. And these answers are the exact same we got from the previous two methods. Now the last method is Gaussian elimination in matrix form. So method number 4 is Gauss elim in matrix form. So I'm just going to rewrite our equations in matrix form. We had 2 minus 5, 3, 5, x1, x2 equaling 1, 14. So what we're going to do is I'm going to say that this row is 1 and this row is 2. I can just ignore the x1 and x2 for now, and I'm going to rewrite this as 2 minus 5, 3, 5 equaling 1, 14. I'm now going to divide row 1 by 2 and row 2 by 3 so that I get 1 and 1 there. So I'm going to go row 1 divided by 2 and row 2 divided by 3. So that would give me 2 divide 2 is 1, minus 5 on 2 is minus 5 on 2, equals 1 divide 2, so that's a half. And dividing this row by 3, 3 divide 3 is 1, 5 on 3, and 14 on 3. So the reason I want to do that is I want to get both of these terms to be 1, 1, because we're now going to subtract it and it makes it a lot easier. So I'm now going to go row 2 minus row 1. So this row 1 is staying unchanged. But this row, it's 2 minus 1. So 1 minus 1 is 0. 5 on 3 minus 5 on 2 would give us 25 on 6. 14 on 3 minus a half would also give us 25 on 6. So now we have 1, 0, value there and a value there. Our aim is to get 1, 0, 0, 1. Okay, that's our aim, and you'll see why in a sec. So we want to make this value a 1 here, which means we need to multiply row 2 by the opposite of this, by 6 on 5, because 25 on 6 by 6 on 5 is 1. So we need to multiply row 2 by 6 on 25. And if we did that, so it would be 0, 1, equaling 25 on 6 by 6 on 5 is also 1. And this row 1 is staying unchanged. So there we have. And now we want to get to a situation where we have 1, 0, 0, 1. So to do that, we need to multiply row 1 by 5 on 2 lots of row 2. Sorry, we need to add it. So we're adding 5 on 2 lots of row 2. So row 2 is staying unchanged. It's 0, 1, equaling 1. Now 1, so we're going row 1 plus 5 lots of 2 row 2. Because if we did that, it would make that go to 0. So 1 times 5 lots of 2 at that point is 1 plus 5 lots of 0, so that's still 1, minus 5 on 2, plus 5 lots of 1 on 2 would be 0, equals, so we're going to have here 1/2 plus 5 on 2 of 1. So this point here would be, so row 1, which currently is 1/2, plus 5 on 2 of row 2, which is 1. So we're going to be going 1/2 plus 5 on 2 times 1, which is 1/2 plus 5 on 2, which is the same as 3. So we've gotten to this stage here, which is what we want. We want a diagonal of 1s and everywhere else to be 0. And the reason is because when we have this situation, putting back in our x1 and x2, equaling 3, 1, when we do matrix multiplication of this left-hand side, we do the row by the column. So 1 by x1 plus 0 by x2 is just x1. 0 by x1 is 0, plus 1 by x2 is x2, equals 3, 1. So whenever you do Gaussian elimination in matrix form, you always want to end up with the diagonal of 1s and everywhere else to be 0. And the reason is because when you expand it out with your unknowns, you just get your unknown. So yeah, that's pretty much it. Guys, hope that helps. We'll see you in the next video.